Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers cumulative frequency and box plots. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 15. The cumulative frequency graph shows information about the marks scored by a group of 80 students in a test. Now, question A says, find the interquartile range. Okay, so we need to find the interquartile range of this data set from the cumulative frequency curve. We're going to do that by looking up the two quartiles, Q1 and Q3, the lower quartile and the upper quartile. Now, Q1 is going to be 1/4 of the way through the data set. Now, you can see from our graph that it goes up to 80. So the highest point on this graph is 80. That means that there were 80 students in the test, and actually they've told us in the question, so I should have known that already. So 80 is the number of elements. Now, if the number of elements is small, you should really add 1 before you divide by 4. But if I've got 80 elements, then adding 1 isn't going to make a great deal of difference. I'm just not going to bother. So 80 divided by 4 is 20. So our Q1 is going to be the 20th value in our data set. It doesn't mean that Q1 is equal to 20. It means that if I find 20 on my cumulative frequency curve, draw along till I hit to the point where I hit the curve, and then switch directions and then draw down, that is going to be my Q1 value. Now I read that as 52. There are 10 little divisions between 50 and 60. So I'm saying Q1 is 52. Okay? So don't be fooled in thinking you just have to divide it by 4 and that's Q1. It just tells you where to find it, 52. Right, so where's Q3 then? Q3 is 3/4 the way through your distribution. So we take our number of elements, we times it by 3 and we divide it by 4. So that is going to be the 60th value then, isn't it, on our graph. So again, we're going to take our ruler, we're going to find 60 on our graph. We're going to read across from 60 until we hit that curve. Like so, and then we're going to change directions and we're going to read down. Okay, so I make Q3 that value down there. So again, using one little square is 1 on my graph, I reckon that is 74. Okay, so my Q3 value is 74. So Q1 is 52 and Q3 is 74, so the interquartile range then is going to be those things subtracted from each other. So 74 subtract 52, what's that? That is 22 then, isn't it? It's the distance from here up to here, that's the interquartile range. 22. Part B says the ratio of number of students passing the test compared to failing the test is 4:1. Find the minimum mark needed to pass the test. So the ratio of passing to failing is the ratio 4:1. Now if you remember, there were 80 students altogether, and if there are 4 parts for passing and 1 part for failing, 4 plus 1 is 5 parts altogether. So how much is each part worth? 80 divided by 5 then. 5s into 80 goes 16 times. That means I need to kind of scale up my ratio by a factor of 16. Okay, so 1 16, that's pretty easy, it's 16. 4 16s, double and double again, 16, 32, 64. So it's 64 to 16. So that means 64 students passed and 16 failed. So what must be the minimum mark needed to pass the test? Well, coming back to our graph, 16 students would have failed and the rest of them would have passed. So it's basically the bottom 16 that are going to fail, aren't they? So what we want to do is find 16 on our graph, on our cumulative frequency axes. So there are 10 divisions between 0 and 20. So 16 is going to be 2 units down then from 20, then it's going to be there. So I'm going to use my ruler then to read across from 16 and then down, and then I can find the mark which the 16th person got, and therefore I know then what they need to get in order to pass. So reading again across to the curve, it's not coming out very well, let's choose a different colour. Let's just use blue. So reading across to the curve, switching directions, about 48. So that's going to be my answer then. 48 marks. Question 12. The cumulative frequency graph summarizes the annual salary P in thousands of pounds of 60 workers in the factory. Part A says, use your graph to estimate the median annual salary. Okay, well, median means middle, and if you've got 60 people, then the middle one is roughly the 30th person. Strictly speaking, it's the 30.5th person, but out of 60 people, that is going to make not very much difference. So I'm just going to look across from 30. So from 30, read across to the graph. When I hit the graph, I'm going to change direction and look down, see where we end up. We end up there, which is 2 squares out of 5 squares between 20 and 30. Now, if there are 5 squares between 20 and 30, then each one of those squares is worth 2 then, isn't it? So 2 little divisions is going to be at 24. So the annual salary is going to be 24, but that scale is in thousands of pounds. So it's 24,000. Now they've already added thousands on the end, so I can just write 24 in here. 24,000. Okay, part B says complete this cumulative frequency table. So we need to work out how many are less than each of these values. So we just need to repeatedly read across from the graph then and fill this in. So less than 10, we need to read up from the graph and across. So up from 10 until you hit the curve and then across. I'll just show you the first one, what I'm doing. So I'm going up from 10 until I hit the graph, and then I'm changing direction and I'm going across, so a bit like the opposite of what I was just doing for the median, reading it the other way. So I'm going to end up there. So again, each little square is worth 2 here, so that's going to be, let's say that's 14. So I'm going to say that's 14 in there. Similarly, less than 20, reading up to the graph and across, I make that 26. From 30, just doing the same thing, that's 36. At 50, that is 50. And at 80, that's going to be everyone, isn't it? It's going to be at 60. Okay, part C says use the information in the cumulative frequency table to calculate an estimate of the mean annual salary. Okay, so I've brought down the cumulative frequencies that we're in the first part. Okay, now if I want to do a estimate of the mean, I'm going to need some more columns really. So what I need to do here is work back from the cumulative frequency back to the frequency. Okay, now normally you work out cumulative frequency by adding the previous frequencies together. So if I'm working backwards, then I need to do the opposite of that, don't I? I need to subtract it from the one that's gone before. So 14, well, it's just going to be 14 in that first category. Now my next category is going to be 26 to subtract 14. It's going to leave me with 12. The next category is going to be 36 take away 26. It's going to be 10. The next category is 50 take away 36, which is 14. And then finally I've got my 60 take away 50 is equal to 10. Now you should find that when you add all those back up together again, it's going to give you 60. Okay, well, it should do. If it doesn't, you've gone wrong. Okay, so there's my frequencies worked out from the cumulative frequency, working backwards. Now usually when we do a estimated mean, we use the mid value of the range. So this one is going to be end up being 0 to 10, so that's got a mid value of 5. This one here goes from 10 to 20, so it has a mid value of 15. This one goes from 20 to 30, so it has a mid value of 25. This one goes from 30 to 50, so it has a mid value of 40. This one goes from 50 to 80, so it has a mid value of 65. Okay, so once we've got those mid values, I need to then multiply it by the frequencies, don't I, to get FP. Just going to budge this over a bit so it fits a bit more on my page. Okay, so I need to multiply my mid value by my frequency to get my frequency times my mid value there. Okay, so 14 times 5, that comes out to be 70. Okay, 15 times 12, 15 times 12, that's 180. 25 times 10 is 250. 40 times 14, 40 times 14 comes out to be 560, and 65 times 10, that's 650. This is going to be sigma FP. This is sigma F. Sigma F is 60. Sigma FP then is going to be those numbers added together. So 560 plus 650 plus 250 plus 180 plus 70. So that all adds up to 1,710. Okay, so then my estimated mean is going to be sigma FP divided by sigma F, which is 1710 divided by 60, which is 28,500, or 28.5. That comes out to be 28.5. So then the as a salary, then that is £28,500. That was not a very nice question. Part D says, explain why your estimate of the median is more reliable than your estimate of the mean. The reason for this basically is that in the mean you have approximated each value to be at the midpoint of the range it happens to be in. So I've approximated all of my figures, haven't I? So for the mean, we used mid values as an approximate. Question 13. The cumulative frequency graph shows the distribution of the heights of members of a rowing club. The first part says find the median. Okay, so the median is the middle one. We've got 120 people altogether, so halfway through that would be the 60th person. So in order to find the median, we're going to read off from 60 and then down. Okay, so find 60 on our cumulative frequency curve scale. Read across to the graph, switch directions, read down to the axes. Now I make that, around about 172 centimeters. 172 centimeters. Now the interquartile range we can do in a similar way. So 60 was halfway through my data, so the quartiles lie 1/4 and 3/4 of the way through. So a quarter of the way through 120, 120 divided by 4 is going to be 30. So my numbers went a bit weird when I printed the scale off, but it should be here. Find 30 on a scale. For some reason when I reproduce this graph, my numbers went a bit wonky on the axes. Hopefully they're good on the copy that you're using. So read across from 30, and then 3/4 of the way through. 30 times 3 is 90, isn't it? So I'm going to read across from 90. So find 90, read across to your curve, change direction, and read down. Okay, so my lower quartile Q1 is going to be 160, and Q3, my upper quartile, I would say that's about 177. So Q1 is, so Q1 is 160, Q3 is 177, so the interquartile range is going to be Q3 subtract Q1, which is 177 minus 160, giving you, what's that, 17? And then finally it says calculate the percentage of members who are at least 180 centimeters tall. Okay, so far we've been reading the cumulative frequency across and then down to find the actual heights. This time we're going to have to go the other way around. So we're going to have to find our height of 180 centimeters, which is here on the graph. And this time we're going to read up to the graph and across. Okay, so reading up from 180 till we hit the curve, and then turning and reading across. I seem to be bang on 100 for mine. Okay, so that is the number of people who had 180, a height of 180 or less. So we want to know the percentage of members who are at least 180 tall. So actually what we want is these people who are taller than 100. Okay, so we want these people here. So what's that as a percentage then? The number who are 180 degrees or taller are going to be these people. How many people are there between 100 and 120? There are 20 of them. Okay, how many people are there altogether? 120. So what is that as a percentage? It's going to be my 20 people who are taller than 180 or as tall as 180, and then over everybody. What's that then as a percentage? And then times by 100 then, isn't it? Oops. To get it as a percentage, so 20 divided by 120 times by 100 comes out to be a 16.6 reoccurring. I'm going to round that up to 16.7 then. So that's 16.7%. 16.7. Question 15. ICRA carries out a survey of 200 families in the north of England on their weekly spending on food. the cumulative frequency diagram summarizes the results. So we've got weekly spend along the bottom and cumulative frequency up the side. Part A wants us to find the median. So the median is the weekly spend of the middle person. Now I've got 200 people. Strictly speaking, I should add 1 and divide by 2, but with this sort of scale it doesn't really matter. It's going to be, I might as well just use 200. So the 200th divided by 2, which is the 100th value. What's that equal to then? The median is going to be what I get from the 100th value, or from the 100th person. So from my graph, I'm going to find 100. I'm going to read across and read down, and that will be my median. Oh, come on, ruler, do 90. There we go. Okay, that's a nice number. It's just landing on 85, I think. No, it isn't. It's 90, sorry. So halfway between 80 and 100, isn't it? So it's 90. So the median is 90 pounds. Okay, so that's 90 pounds. And then the second part wants the interquartile range. So the interquartile range is the value of the person a quarter of the way through and 3/4 of the way through subtracted from each other. So if I've got 200 people and I divide that by 4, again, really you should be adding 1, but with 200 it's not going to make a lot of difference. So it's going to be our 50th value. That's Q1, isn't it? Okay, so Q1 is going to be reading across from 50. So where's 50? 50 is halfway between 40 and 60, isn't it? There. So reading across to the curve and changing direction. Reading down. So that is going to be my Q1. That was Q2, the median, wasn't it? So Q1 is, what's that on the scale? So we've got 5 divisions between 10 units, in which each one of those is worth 0.2. So I think that one is pointing at, it's either 78 or 77. I think I'm going to go for 77. I'll read that as 77. Q3, that's going to be is 200 divided by 4 and times by 3, isn't it? It's going to be the 150th value. So we're going to read across from 150 then on our scale. So 150 halfway between 140 and 160. So read across to the curve, change direction, read down. I think I read that as bang on 100. So that's Q3. So Q3 is 100. So therefore then the interquartile range is going to be equal to Q3 subtract Q1, which is 100, take away 77, it's going to be 23. Icarus says 15% of these families spent over £120. Is her statement correct? State the evidence you have used in making your decision. So have 15% of these families spent over £120. Okay, so I think we can use the top 15% here, can't we? So what we're looking for then is the top 15% of 200 people. Now 15% of 200 is 30, isn't it? So it's 30 people. So 30 people down from 200 is, we need to look across at 170, don't we? So let's get the ruler out. So 15% of 200 is 30. So 30 down from 120, what does that give me? Read across to the graph and read down. What's that then? That's 112, which is a bit lower than what she thought, isn't it? So you can say that the top 15% spent over £112. I suppose it's true that they must, no, it can't be true then that they're over 120, because some of those are going to be spending less, aren't they? So how can we write that down? I think we can say that the top 15% spent over £112. Oops. £112. So she is incorrect. Okay, and then part C says, in a survey of 200 families in the south of England, the median weekly amount spent on food was £84 and the interquartile range was 28. Make two comparisons between the weekly amount spent on food in the north of England and the south of England. State the evidence you've used to make your comparisons. So we've got an average value and we've got a measure of dispersion for both groups. So we're going to compare like with like. We're going to compare the averages, the median averages for the two areas of the UK, and then we're going to compare the two interquartile ranges to give us an idea of dispersion. So let's compare the averages first. So the average in the north of England was 90 and in the south it was 84. So we can say that on average, families in the north spent more on food, and that was £90 versus £84, wasn't it, for the medians? Okay, so we've compared the averages and we've said the families in the north spent more on food. Then the ranges, or the interquartile ranges, okay, so it's a much smaller value for the south, which means that they are much more similar to each other than the north. So we're going to say that there is much greater variation in spending, not is spending, in spending by families in the north, and we got that from interquartile range. Okay, so that's my evidence. So we compared the interquartile ranges and we can say that there's much greater variation in the families in the north. Okay. Question 15. 60 people take part in a quiz and the graph summarizes their score. Now you can see we've been given a cumulative frequency curve with all the marks on it. Now we're asked to use the graph to estimate what fraction of the 60 people scored more than 30 marks. Now here's 30 on my graph. Now to work out how many people scored more than 30, first off we need to look up from 30 along our graph. So I'm going to use a ruler and show that. It's going to mark on reading up from 30. It's a good idea to show your work in this way because it counts as method, and then along from there, and I can see then that what mark is that? Each one of these little squares is worth 2, isn't it? So 10, 12, 14. It's halfway between 14 and 16. I'm going to say that's 15. So I'm going to say that 15 people scored 30 marks or fewer. Now, if we want to work out how many scored more than 30, then actually what we're looking for is the people from there to there. So the number of people there are between the mark 15 and 60. So I would estimate that as 60 take away 15, which is 45 people. So writing that as a fraction, for some bizarre reason this is asking for a fraction. So 45 60ths of the people, which I suppose we can cancel down to 3/4 of the people scored more than 30 marks. Okay, part B. Estimate the median score. Okay, now the median score is at the halfway point. If you've got 60 people, then the median is going to be 60 plus 1 over 2. It's the 30.5 value, which we can read off from our graph again. So coming back to our graph, we need to read across from, well, 30.5, but I might as well just read across from 30. So again, reading across the graph in the other direction this time. So along from 30, and then change direction, go downwards. Now I estimate that to be just slightly below 70. I'm going to say that it's 69. So estimate the median score, 69. For now. Question 15C. The same people take part in a second quiz. The graph summarizes their scores for both quizzes. So we've got our original curve, quiz 1, and our new curve, quiz 2. Jack states the quiz was easier than the first quiz because the graph is higher. Does the graph support this statement? Give a reason for your answer. Now, though at first glances it might appear that people would have done better at quiz 2 than quiz 1, that's not actually how cumulative frequency graphs work, that the higher the graph is, the better that you're going to do. Now let's consider what we just did, finding the median value. So if I read off at 30 for both tests and find out what the median is for both of them, so we've got two values that we can look up here. So the median for the second test is there, look. And for the first test or quiz, it was up here. We said it was 69, didn't we? So we said this one was 69. Now we can see that the median for quiz 2 is all the way down here. It's 19. So on average, people did a whole lot worse on quiz 2 than quiz 1. So was quiz 1 easier? I would say no. The median for quiz 2 was 19, much lower than quiz 1. Question 15. Here is some information about the test marks of 120 students. And I've got a frequency table here, and you can see that it's grouped. So I know the marks from 0 to 10, 10 to 20, 20 to 30, and so on. Okay, now the first question for 1 mark is to complete the cumulative frequency table. So the values for m less than 10 is just going to be those 20 there, isn't it? The values of m less than 20 is going to be those 20 plus the 28. So 20 plus 28 is 48. That's already been given. Less than 30 is going to be the 20 and 28 with the 40, which I can just get by adding 40 onto 48. So that makes 88. Then the next one I'm going to get by adding 20 to everything that came before. So 88 plus 20 is going to be 108. And then finally add on the 12, takes me to 120. It's always a good idea to just check that this number here at the end is the same as the number you were given to start with. And then you can be pretty confident that you've got it right. Right, what does part B says? Okay, so now we need to draw that information into a cumulative frequency graph. Now, when you're plotting cumulative frequency curves, you need to plot cumulative frequency against upper class bound. So 20 is going to go against 10, 48 is going to go back against 20, and so on. So let's plot those on. So hopefully the examiner's already provided us with the axes. We just need to plot the points straight on. As you can see, I've got marks along the bottom and cumulative frequency up the side. So the first cumulative frequency, which was 20 marks less than 10, was 20 people. So mark less than 10 was 20 people, is that point there. We can also plot an additional point, which is our lowest point on the graph. We can plot 0 against whatever this lower class bound is on our first graph. In this case, it's going to be 0, 0. So I'm going to plot an extra point here, 0, 0, and then one at 10, 20. The next one's going to be at 20, 48. 20, 48. Now I've got how many squares between 40 and 60? I've got 1, 2, 3, 4, 5 little squares between 40 and 60. So I've got 5 squares spanning 20 units. So each one of those little squares is going to be worth 4 then, isn't it? So it's going to be 40, 44, 48, 52, 56, 60. I think it's good just to count up like that, just to make sure you haven't made a mistake. So each one of those little squares is 4. So if I want to plot 48, it's going to be 2 squares up from 40, isn't it? So 20 is going to be here at 48. Right, what's the next value? M is 38 against 88. So 30 against, well, there's 80, and 2 more squares up is going to be 88 then, same as last time. And then finally, oh no, I've got 2 more. M is 40 against 108. 40 against 108, so 2 squares above 100. And then 50 was at 120, wasn't it? Okay. So you should get this distinctive S-shaped curve when you draw a cumulative frequency curve. It always starts low and ends high. I'm just going to join it up with a nice smooth curve. Try and go through the center of each of the points that you have marked. Okay. What you don't want to do is have double lines. Okay, that will get you marked down. You shouldn't have double lines on it. And you don't want to miss the points entirely. You need to go skew at each point and not have kind of multiple lines. If you drew more than one line, just make sure one of them is rubbed out nicely. Okay, so I think we've drawn the graph nicely there. What's next? Part C says students who scored 15 marks or fewer take another test. Use your graph to estimate how many students took another test. Well, 15 marks. So 15 marks is here. Just going to put the ruler on 15. And I'm going to draw up to the curve. And I'm going to change direction. And I'm going to draw across to the axes. What's that then? So that there then is the number of people then who got 15 or fewer marks. Oops, come back. So we said each one of these little squares is worth 4. So I make that 20, 24, 28, 32. Halfway between 32 and 36. So I'm going to read that as 34. I'm going to go for 34. Okay, now you'll get a little bit of leeway, you know, anything between like 33 and 35 I think would be acceptable there. Okay, let's move on. Question 16. The cumulative frequency graph shows information about the masses of 50 apples. So we've got the mass of apples along the bottom, and we've got that distinctive S-shaped curve for cumulative frequency at the side. Okay. Use the graph to estimate the median mass of apples. Now, median is middle, and if we've got 50 apples, then the median value, well, normally you would add 1 and divide by 2 to find the median. So 50 plus 1, 51 divided by 2, 25.5. But on a scale like this, you might as well just use the top value of your cumulative frequency, because it doesn't make a lot of difference. Looking up at 25.5 or 25 doesn't make a great deal of difference to this graph. So you're allowed to just use the 50, divide it by 2, and then use that as your lookup value. Okay, so getting a ruler out, finding 25, half of 50 on the cumulative frequency scale. It's there. Okay, and then carefully reading across to the curve, and then changing direction, and then reading down. See, I end up down here. What's that? It's one little square up from 105. Now there are 5 little squares between 105 and 110, so each square must be 1. So I reckon that's 106 grams. So I'm going to say my estimate for the median mass of apples is 106 grams. Okay, now marking the graph like this is good method, so it's good to draw it on the graph as evidence of your working. Okay, so next part says estimate the proportion of apples that have a mass greater than 115 grams. Okay, so here we're going to use the graph the other way around. We can find 115 grams on the graph, and this time we're going to read up to the curve and across. So just going to switch color pens. So reading up from 115 up to the curve, switch directions, and then read over to the cumulative frequency scale. You can see that ends up there. Go away, ruler. So what's this scale? I've got 10 little squares between 40 and 50, so again each one must be 1. So I'm reading that as 42. Okay, so that value there is 42, but is that the answer to my question? It says estimate the proportion of apples that have a mass greater than 115 grams. This actually tells me that there are 42 apples that have a mass of 115 grams or less. So this tells me kind of this area down here actually. I don't want that area though. I want to know how many apples are more than that. So I have to take 42 away from 50, and that will tell me how many apples are greater than that weight. So 50 subtract 42 is my answer. So it's going to be 50 subtract 42, which is 8 apples. Question 16. The cumulative frequency graph represents the masses of 40 necklaces. Part A says a jeweler buys every necklace with a mass greater than 21 grams. Use the graph to estimate how many he buys. Okay, well, to do that, what we're going to have to do is get our ruler out and find 21 on our mass axis. Going to read up to the graph, and then we're going to spin round, change direction, and we're going to read across to the cumulative frequency. Okay, now that's pointing at the number 16. So that's 16 there. Okay, so what does that mean? How many necklaces have a mass greater than 21 grams? Now, those 16 there have a weight less than 21 grams. Now, if we want the ones that are greater than 21 grams, we're talking about these ones up here, aren't we? They're going to correspond to this section of the graph, actually. So how far is it from 16 up to the top of the cumulative frequency? That's going to be 40 minus 16. So they're going to be 40 minus 16, which is 24 necklaces then that have 21 grams or higher as their value. Now part B says the lowest mass was 3 grams, the highest mass was 28 grams. Draw a box plot to represent the data. Okay. Well, a box plot is going to go from the lowest to the highest, and it's going to have a box in the middle from Q1 to Q3. It's going to have the median in the middle. So it's going to look like that. Okay. Now we're told what the lowest mass is. It's 3 grams. We're told what the highest mass is. It's 28 grams. Now we need Q1, the lower quartile. Q2 is the median, and Q3 is the upper quartile to finish our graph off. Okay, so this has got a cumulative frequency of 40. So if we take 40 and we divide it by 2, that's going to tell us where the median is. So 40 divided by 2 is 20. So we're going to read across from 20 to the curve and then down, and that's going to tell me Q2, the median value. Okay, down to here. Okay, so on my graph, that seems to be about 21. Okay, so Q2 is going to be 21. Okay, and then what about Q1 and Q3? Now, Q1 is a quarter of the way through the data. If half of the way through the data is at 20, then a quarter of the way through the data is going to be at 10. Now with a small number of items, you have to kind of add 1 before you divide by 2 and 4, but when you have lots like 40, it doesn't really matter. And then 3/4 of the way through is going to be 10 plus 20, it's going to be at 30, isn't it? 30 is 3/4 of the way through 0 to 40. So I'm going to look across at 30 as well. Just spin around and go down the other way. So Q3 is going to be down here, or up here. And Q1 is going to be here. Okay, so I need to read those values off as well. I think Q1 is going to be about 18. Let's get rid of the ruler. 18. Q3 looks to me to be 24. Okay, so now I've got all the values that I need for my my box plot. I'm going to actually draw those on the graph I've been given. Okay, so I'm going to draw a line at 3 to represent the lowest value. I'm going to draw a line at 18 to represent the lower quartile. I'm going to draw a line at 21 to represent the median. I'm going to draw a line at 24 to represent the upper quartile. And I'm going to draw a line at 28 to represent the highest value. Okay, so once I've got those down, then I'm just going to finish off the box plot. So the box is going to be here between the Q1 and Q3. Okay, and then the whiskers are going to spread out from the ends of the box down to the upper and lower values. Okay, so I'm just going to draw a line from the end of the box, some upper and lower value like that. Okay, so there's a kind of neater version. So I kind of do recommend just sketching it out first, get all the values on your little sketch, and then once you've got all the values, then you can draw it neatly on on your graph paper. What you don't want to do is just go rush ahead and draw it on the graph paper and then get it wrong. So plan it, and then you can do it first time on the graph without making a mistake. Question 17. 75 people attend a clinic. Their ages are recorded and a cumulative frequency diagram is drawn. Okay, so we can see we've got a cumulative frequency curve here. A nurse makes a statement about the ages of the people at the clinic. He says more than twice as many people are in their 60s as in their 50s. Is he correct? Tick a box, yes or no. Show working to support your answer. Right, so where are the people who are in their 50s? Well, the people in their 50s are going to be between the ages of 50 and 60, aren't they? So I'm going to look up 50 on the graph until I get to the curve. Then I'm going to turn around and I'm going to go this way. And I'm going to find out how many people are 50 or less in age. Okay, that's going to give me 13, I believe. So there are 13 people who are 50 or less. Okay, let's carry on. Let's look at 60. How many people are 60 or less? So again, reading up to the curve and then across. That tells me that there are 30 people who are 60 or less. So there's 30. Okay. And then finally I do need to look up the 70-year-olds, because people in their 60s go up to 70 years of age. Okay, so I'm going to have to look up a third value for my graph. I believe that is 66. So 66 people are 70 or less. Okay. Right, so now I need to work out how many people are in their 50s and how many people are in their 60s. So what I need to do for people in their 50s, if you think about it, if there are 13 people who are age 50 or less and there are 30 people who are age 60 or less, then there've got to be 30 minus 13. There's got to be 17 people who are between the ages of 50 and 60. Okay? And then people in their 60s, that's going to be the people who are less than 70, which is 66, minus the people who are less than 60, which is 30, and that leaves you with 36 people who are in their 60s. Now remember the nurse said there are more than twice as many people in their 60s as in their 50s. Is 36 greater than 2 lots of 17? It is. So I can say that 36 is greater than 2 times 17, which is equal to 34, isn't it? Okay, so he's correct. Okay, so I'm going to tick yes. There are more than twice as many people in their 60s than in their... Question 17. The cumulative frequency graph shows information about the masses of 200 apples. Part A says estimate the median mass. Okay. Now the median is going to be halfway through our data set. When the number of points is small, it's better to add 1 before you divide by 2. But when you've got 200, probably the easiest way is just divide straight by 2. That means I need to look across from 100 to find the median. So find 100 on my cumulative frequency, read across to the graph, change direction, read down. Actually drawing the lines on it like this is good good method to show. So it's a good idea to do it. So what's that then? It's between 80 and 85. So I've got 5 divisions between 80 and 85. Each one is worth 1. That's going to be 83 grams, then, isn't it? So the medium mass is going to be 83 grams. B, apples with mass 90 grams or less cost 32p. Apples with mass of more than 90 grams cost 39p. Estimate the total cost of the 200 apples. Well, 90 grams is here, and if I read up to the graph and across from 90, just switch color, let's go for red. It's going to go up to the graph there, change directions, and read across to the axes. Make it about there. Now what's that? So I've got 140 and 160 here. I've got 5 divisions in between spanning 20 points. So each division must be 4. So it's going to be 140, 44, 48, 52, 56. That's 156. Okay. So that means that 156 apples are going to be 90 grams or less, which means the remainder, which is 44 apples, are going to be more than 90 grams. Okay, so then the total cost is going to be my 156 apples at 32 pence. They were the cheaper ones, weren't they? Plus my 44 apples at 39 pence. Okay, I think that's gone a little bit off the screen. Let me just budge that over so you can read it. Type that into the calculator. 156 times by 0.32 plus 44 lots of 39 pence. That comes out to be £67.08. So that's equal to £67.08. Question 7. The table shows information about the heights of 60 athletes. Complete the cumulative frequency table. Okay, so we've got the first 3 values in my cumulative frequency table completed. This first one, when h is less than equal to 150, that comes from the left-hand band of the first group there. So there's nothing left than 150. So then the next one down, h is less than 160, comes from here. Let's those 4 there. Okay, that gives you that one. And then h is less than 170 is going to be that one and that one added together, isn't it? You add those 2 together and that's going to give you the 16. So I'm going to get the next one by adding on the next value as well. So if I add on all those 3 values, so add another 35 onto my 16, that's going to give me 35 plus 16, that's 45, 51. And then adding on the 7 next, that's going to take me up to 58. And then finally adding on the 2, and that gives me 60. Always worth checking that this last number here matches with your total that you've been given at the start, and then you kind of know that you haven't made a mistake with your adding up. Okay, so I've completed my cumulative frequency table. What next? Part B says circle the class interval that contains the lower quartile. Well, Q1 is 1/4 of the way through the data, so it's the n plus 1 over 4th value. Okay, but when n is high, which is in this case 60, we kind of ignore the plus 1 because it doesn't really do very much. Okay, so I would just say that is 60 over 4. It's roughly the 15th value. Okay, so you know, just taking the 60 divided by 4, that's going to give me 15. If n was small, like less than 20, I would be adding 1 because otherwise it does make a bit of a difference, but at this amount it doesn't really. So where's 15? Where's the 15th value then? Well, the first 16 are in here, aren't they? Okay, so the 15th value is going to be in that group there. So it's going to be in the 160 to 171, isn't it? It's going to be in that group. Part C says draw a cumulative frequency diagram to represent the data. Okay, so just going to go through point by point plotting these on then. So 150 goes with 0. So that's my first point there. 160 goes with 4. So yeah, each one of these little squares is 1, isn't it? So it's just the 4th square up. 170 goes with 16. So 1 square above 15. 180 goes with 51. So that's just 1 square above 50. 190 goes with 58. So that's 2 squares down from 60. And then finally 60 goes with 200. There. Okay, so once you've plotted your points, join them up with a smooth cumulative frequency curve. Make sure you have a single line passing through each of your plotted points. Kind of flattens out at the top, kind of ends up with a kind of a 0 gradient at the top. Right, okay, I think that would do. And then finally, sorry, my question's kind of gone off the page. Let me just budge it over. So, estimate that the number of athletes whose height is more than 176 centimeters. Okay, well, we can easily look up 176 from the graph. So taking our cumulative frequency curve and drawing a line up from 176 until we hit the curve, and then turning around and going this way. That's pointing to somewhere between 44 and 45. Okay, I'm going to just round it down. I'm going to say it's 44. I think it's slightly closer to 44 than 45. So what is that telling me? Well, that tells me that 44 people, all these people down here, have a height of 176 or less. Okay, so just make a note of that. So 44 have height less than or equal to 176. So, but we want to flip it around. We want the ones that are more than 176. So what we actually want is we want all these people up here, the ones who have a height higher than 176, and that corresponds with these people on the graph. Okay, so we get that by taking that 44 away from the total, which is 60. So 60 minus 44 is 16. So that's the answer then, isn't it? So 16 have height greater than 176. Okay? Now, if your graph is pointing at a different value, you just go with your graph. You know, there's, I don't know if you can see, ooh. Now, if you're getting a different value from 44 when you look yours up, and then don't worry too much. There's quite a bit of variation how I could have drawn that line between those 2 points. They're quite far away from each other. In which case, you would have got a different value for that to look up. The examiners check your graph, so whatever your graph says is the value that you should use. There'll be a range of possible solutions in the paper that are acceptable, and they do check your working against your graph. So yeah, don't worry if you haven't got 44 exactly. As long as it looks right on your graph, then the answer is correct. Question 18 gives us a frequency table, well, a group frequency table, and we need to draw a cumulative frequency graph to go with it. Now, in order to draw a cumulative frequency graph, we're going to need cumulative frequency. They've handily left us a column on the end here to calculate it. Cumulative frequency goes in here. We already explained this earlier, but that one is going to be the same as that. The next number you get from adding the number above with the number to the left. So this one here is going to be 9, and then the next one is going to be 44, next one is going to be 74, and then 84, 92, and 100. And when you get to the end of the list, always a good idea just to check that you've got the same number as you should have. They haven't told us how many we should have here, but it's a nice round number, so I'm happy with that. Okay, so now we've got this, we're going to be plotting cumulative frequency, these values here, against upper class bound. We're going to be plotting them against these numbers. Okay, so the first point I need to plot is 80 against 0. So 80 goes with 0. The next point is 9 goes with 100. So 100 goes with 9, and so on. I'm going to plot all the others. So I'll pause this, plot the others, and get back to you. Okay, having drawn plotted all my points. Now I need to join them up with a nice smooth curve. It's kind of easier said than done on the computer, but I'll do my best. Try and pass through the center of each of the marks that you made. Okay, that's alright. So you tend to get this S-shaped curve with cumulative frequency. If your graph starts heading downwards again, obviously you've made a mistake. Right. Estimate the number of these films with a running time of less than 2.5 hours. So 2.5 hours is how many minutes? That's 150 minutes, isn't it? So what we need to do is read up from 150 and across. So let's get the ruler out. Put it on 150. Oops. So we're going to draw up from the 150 until we hit the curve. Right, okay, so this value here is 82. So estimate the number of films have a running time of less than 2.5 hours. It should be 82 films. Question 8 has a group frequency table showing the travel time that 80 teachers took to get to work. And we're being asked to draw a cumulative frequency graph of this data. Now, cumulative frequency is where we plot the upper class boundary against the cumulative frequency. So we're going to class upper boundary, which is 20 in this case, and 40 and 60 and 90, and we're going to plot that against cumulative frequency, which is 12 plus, we add those two together to get the next one, which would be 44, and then we add all three together, or 44 plus 25 to get the next one, which is 69, and then finally 80. It's always a good idea just to check this last value matches with the total they give you in the actual question. So that looks good. I'm going to plot those points then on my graph. So 20 versus 12. So 20 goes with 12. It goes there. The next point is 40 with 44. So 40 with 44. We can plot 60 with 69. 60 and 69. It's going to be there. And then finally 90 with 80. So 90 with 80. Now we can also plot another point. We can plot the lower class boundary here against 0. So I can plot one at 0, 0 as well. So my graph actually starts there. Now I'm going to join those up with the distinctive kind of S-shaped cumulative frequency curve. Try and make sure you use one continuous line passing through the center of each of the marks that you made, like that. Right, and then the next question says, estimate the number of teachers who took between 50 and 70 minutes to travel to work. Okay, so 50 is here and 70 is here. So in order to do that, we're going to have to read up to the graph at 50 and 70 and find out how many teachers that represents. So just join up to the graph. 50 and 70 and then across. Now we can see that we've got values 58 and 74 there. So number of teachers, it's going to be that, well, it's going to be the distance between the two of those, the distance from there to there. So it's going to be 74 minus 58. Which is, no it's not, it's 16. Question 19. Here is some information about the marks for 60 students in a test. So we've got a group frequency table, and underneath it says, on the grid, draw a cumulative frequency graph. Okay, so cumulative frequency is upper class boundary against cumulative frequency. So upper class boundary is the highest value of each one, so it's these numbers here, isn't it? So I'm going to be plotting 50 against 9. I'm going to be plotting 60 against those two added together. 9 plus 16 is 25. I'm going to be plotting 70 against, well, 25 plus 20 is 45. I'm adding those together, aren't I? So my 25 plus my 20 gives me 45. And then I'm going to be plotting 80 against those, which is 45 plus 8, which is 53. And then finally I'm going to be plotting 90 against 53 plus 7. It's going to be 60. Always good just to check that this number here is the same as the one up here. It is, so I'm confident I've added up my cumulative frequencies correctly. Now it's just a matter of plotting. There's one other point I can plot. I can plot the lowest class bound here against 0. So my first point is going to be 40, 0. 40, 0 is going to be that point. My next point then is 50 against 9 and 60 against 25. So 50 against 9 and 60 against 25. Next 2 points, 70 against 45 and 80 against 53. So 70 against 45 and 80 against 53. And then finally, I've got 90 at 60. Okay, let's just zoom out a bit so I can see the whole graph. So you normally get a distinctive S-shaped curve when you plot in cumulative frequency. Might be a little bit hard to see here, but it's more or less there. Let's just join those up with a straight line. So you want to be joining these up with a smooth, continuous curve passing through the center of each of your points. And kind of topping out at your top value up there. Okay. Question 19b asks, use your graph to estimate the lowest mark of the top 20% of students. Now there were 60 students altogether, so the top 20% then, 20% of 60, well 10% of 60 is 6, so 20% is going to be 12 students. So we're looking for the top 12 students. So on our cumulative frequency, if we're going to have 60 at the top and we take away 12, we get 48. So that is where I need to read across from on my graph. So cumulative frequency of 48. Let's get the ruler out. I'm going to read across from 48 till I get to my graph. get to my graph, I'm going to change direction. Read down. So it's there, isn't it? So what's that on my graph? That is about 74 or 73 and a half. So I'm going to round that up to 74, I think. So use your graph to estimate the lowest mark of the top 20% of students. It's about 74. Question 19. Type A batteries and type B batteries were tested. The cumulative frequency diagram shows the information about the battery life of type A. And we can see it's got one of those distinctive S-shaped cumulative frequency curves. Estimate the interquartile range for type A. Okay. Now you can see that we've got altogether, we've got 80 batteries in this sample. Okay, now the interquartile range is the middle half of your data. So basically you need to look at the range between 1/4 and 3/4 of the way through your data set. So 1/4 of 80 divided by 4 is 20. So we're going to read across from 20 to the graph. So from 20, I'm going to read across to the curve and then switch down, and that will be our Q1 value. Not drawn along the ruler particularly well today. What's going on? Okay, now it's done it. So, and then 3/4 of the way through the data is going to be reading across at 20 times 3, 3/4. It's going to be at 60. It's going to be easier. Okay, and then when we hit the curve, we're going to switch and draw down. So my Q1 is there. Look, that's Q1. Lower quartile. My upper quartile is here. That's Q3, which is 3/4 of the way through. Q2 is the median. So Q1 is lower quartile, Q3 is the upper quartile, and then the interquartile range then is the distance between those. Interquartile range, which is Q3 minus Q1. So from my graph, I can see that Q3 is 1400 and Q1 is 1100, and 1400 minus 1100 is 300. Question 19b. Estimate the number of type A batteries that had a battery life of more than 1600 hours. Okay, let's go back and look at the graph. More than 1600 hours. Well, 1600 hours on my graph is here, look. So we're going to use our community frequency curve the other way around this time. So rather than reading across from the frequency and down, we're going to read up from 1600 until we hit the curve, and then we're going to change direction and read across. Okay. Struggling to draw on this line today. Go on, stop being annoying. Okay, done it. Right, so what's that value there then? That reads to me like 76. So up there is 76. Now what does that tell me though? That tells me that 76 batteries had a battery life of 1600 hours or fewer. Okay. Now the question didn't ask me that, it asked me how many batteries had a life bigger than 1600. So it's not the 76 as my answer, it's my difference between 76 and the top, which is 80. So the difference between 76 and 80, those batteries had a life longer than 1600 hours. So it's going to be 80 subtract 76, which is 4. So it's going to be 80 subtract 76, which is equal to 4 batteries. Okay, now part C says the box plot shows information about battery life of type B. On average, which type had the greater battery life? Tick the box. Well, the greatest battery life is going to be given by the median here, I suppose. So it's like the average life expectancy. So here the median is the Q2 value. It's the one in the middle of your box plot. And if you read down, you can see that it's 1300. So type B has a median value of 1300. So let's compare that with the median value for type A then. Going back to the graph. Now we didn't work out the median, we worked out the lower and the upper quartiles. Now we can find the median by looking across from halfway through the values. So again, reading across from 40. Ruler, what's up with you? Okay, it's drawing again now. And then switching around and drawing down. Okay, I can see my Q2 value or median is there. So I read that to be what, 3 out of 5 little squares up from 1200. So if there are 5 little squares between 1200 and 1300, which is a span of 100, then each little box is worth 20, then, isn't it? 20, 40, 60, 80, 100. So 3 little boxes is going to be 60. So I read that off as 1260 as the median value from type A. So we said that type B has a median of 1300 and type A has a median of 1260. So B is the biggest medium, isn't it? So what do we have to tick? On average, which type has the greater battery life? B does. State how I chose my answer. Well, I've shown that. That's all fine. I've done everything. Question 22. Here is some information about the miles per gallon of 60 cars. And we've been given the miles per gallon and the frequency in the group frequency table, and we've been asked to draw a cumulative frequency graph. Okay, now when we draw a cumulative frequency graph, we are plotting upper class boundary, which is these ones, against cumulative frequency. So let's just use this table here to work that out. So my upper class bound is going to be those values 50, 60, 70 and 80. And my cumulative frequency, well, my first cumulative frequency is the same as my frequency. My next one is going to be those two added together. 6 and 16 is going to give me a 22. Now my next cumulative frequency is going to be those 3 added together, but I already know the first 2 add to 22, so I just need to add the 28 to my 22 to get 50. And then finally that one there, I add all 4 together, or my 10 to my 50, which gives me 60. Always a good idea to just check that is the same as the answer that they give you at the top, because it is an easy mistake to make during a test. Okay, so now I've got my cumulative frequencies and my upper class boundaries. I can start plotting the points. Now there's actually an additional point I can plot first. I'm going to plot 0 against the lowest value there on my cumulative frequency table, my frequency table. So I'm going to plot 0, 40 as my, or 40, 0 as my first point. So my first point is going to be here, 40, 0. My next point is going to be at 56. So 56. Each one of these little squares is going to be worth 2, 2, 4, 6, 8, 10, isn't it? So that's going to be 6 there. My next one is going to be plotted at 60 and 22. So 60 goes with 22, is that point there. My next one is 70 at 50. 70 and 50. And then finally at 80 and 60. 80 and 60 goes there. Once you've drawn your points, you can join them up with a nice, smooth, continuous curve going through each of the points. Should give you that distinctive S-shaped cumulative frequency curve once you're done. Okay. Right, use your graph to work out the interquartile range. Okay, now the interquartile range is the range of the middle half of your data. So if I've got a cumulative frequency of 60, if I've got 60 values, then 1/4 of the way through that, 60 divided by 4, is going to be 15. So my lower quartile is going to be at 15. Let's just get a ruler out and draw on at 15. So drawing across from 15 until I hit my curve and then draw down. Should give me my lower class, my lower quartile. So it should be there. And then my upper quartile is going to be 3/4 through my data set. So times in 15 by 3 gives me 45. So again, I'm going to read across from 45 to find my upper class bound. Sorry, my upper quartile. Spin that round. Okay, so that's going to be my Q1 there, and that's going to be my Q3, the upper quartile and the lower quartile. So I make Q1 equal to, what's that, 57? Between 56 and 57. I'm going to go for 57, I think. And then the Q3 value looks to be 68. So then my interquartile range is going to be Q3 subtract Q1, which was my 68, subtracting my, what was it, 57? 57. 57, 68 subtract 57 is 11. So the interquartile range then is going to be 11 miles per gallon. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.